Okay.
Yes, ma'am.
So today is our first session on polynomials. So let's wait for a couple of minutes and then we will start. So we will learn everything about polynomials. What are they? How how are they? I mean, how they look? What are the equations, graphs, and all those things. Okay. So it's important and basic topics. Okay. So we'll start at 8:10. Yes. So this is week 4 summary. Okay. So let's start with polynomials. So, in between, if you guys have any doubt, you can just unmute yourself and let me know. But don't disturb in between the concepts. Okay. So, at the end of the topic, you can ask your doubt. It is live streamed. It's, it's denoting that it's live streaming service. Okay. So, let's start with polynomials. So, what are they? So, first of all, polynomials are actually specific kind of functions which are made of some variables. So, in our course, we are dealing with only one variable polynomials. So, one variable polynomials means those polynomials which uses only x. Right. So, we are restricting ourselves to use only one variable x. So, such kind of polynomials are those kind of polynomials we will see in our course. Okay. So first of all, let's define what is a polynomial is. So any function, function which looks like p of x is equals to some a n x to the power n plus a n minus 1 x to the power n minus 1 plus and so on plus a1 x plus a naught. Right? Where what are these ans? So ans are actually any real numbers you can take, and here we are restricting that whatever highest power is there, then the coefficient of that highest power is actually non-zero. And here obviously n is any natural number you can consider, and here we are taking an is not equals to 0. And here you can say that all AIs are actually real numbers. So such kind of function is known to be a polynomial. For example, you can say that we can consider a very basic example. Suppose x to the power 4 plus x cube plus x square plus x plus 1. So this is a basic kind of example of a polynomial. Okay. So now we are going to learn so many things about polynomials. So I'll start with basic terminology. So what is the degree of a polynomial is? Degree of p of x. Okay, so degree of p of x means the highest power present in the polynomial of x, right? So you can say that the largest power of x. Okay, so that is known to be a degree of polynomial. So for example, in this example, what will be the degree of p of x? So degree of p of x is nothing but 4, because the largest power of x is nothing but 4, right? It's known to be the degree of a polynomial. So now, as we have learned that how we can add to natural number, how we can add to integers, similarly, we will learn how to add, subtract, multiply and divide any two polynomials. So these are basic operations. You guys may have familiar with this thing. So suppose you have a polynomial, you have two polynomial p of x and q of x. So suppose I'll take a particular example instead of going abstractly. So suppose I have a polynomial p of x to be 3x to the power 5 plus 6x to the power 4 plus 2x square plus x plus 1. And if I want to add this polynomial in the polynomial q of x is equals to x cube plus x plus 1, then what I'll do, I'll add the same power of x. For example, if I want to compute p of x plus q of x, then see here there is no power of 5. So what you can do, you can write this polynomial in this way too, that 3x to the power 5 plus 6x to the power 4 plus 0x cube plus 2x square plus x plus 1, so that you can get all the powers of x, and you can consider coefficient to be equal to 0 if there is some missing power of x. It's just for simplification, you can directly also add. So this polynomial also you can write as 0x to the power 5 plus 0x to the power 4 plus x cube plus 0x square plus x plus 1. Right. Now, if you want to add two polynomials, you will add the same power of x with the same power of x. That means you will add this 3x to the power 5 with 0x to the power 5. So you'll get 3x to the power 5. Right. Now, in the second step, you will add 6x to the power 4 with 0x to the power 4. So you'll get 6x to the power 4. And if you do the same thing, here we have 0x cube plus x cube, that is x cube, 2x square plus 0x square, that is 2x square. Now x plus x, that is 2x, and 1 plus 1 will be 2. So this is the addition of two polynomials. Similarly, there is no specific thing about addition. Similarly, you can subtract two polynomial too. So it's a basic operation how to add and subtract any two polynomials. We also know how to multiply two polynomials. So if you want to multiply p of x into q of x, then what you have to do, you have to multiply term by term. So that means suppose here we have p of x to be 3x to the power 5 plus 6x to the power 4 plus 2x square plus x plus 1. In this polynomial, you want to multiply x cube plus x plus 1. Then what you will do, you will multiply term by term. Term by term means first of all, you will multiply x cube
Wait,
with the... Hello? Okay. So what you will do, first of all, you will multiply x cube with this whole bracket, then plus x, then the whole bracket, and then plus 1, and then the whole bracket. And then you simplify it. That's how you multiply any two polynomials. So it's a basic thing. Yeah, I'll slow down my speed. But see, these operations are very basic. That's why I'm uh, hurrying because... okay, so let's see. So I don't think is there any doubt in adding, subtracting, and multiplying any two polynomials, right? Right. Now, the operation of division, you can say that, okay, it's a little bit different than dividing any two real numbers. But let's see how we can divide any two polynomials. So if you want to divide p of x with q of x, so divide p of x with q of x. Okay, so this division you guys may have learned in your 10th standard, but let's recall it. So I'll take again. I'm not going abstractly. That means I'm not taking any abstract polynomial as the sir did in the lecture. So I'm just going by the example because I think it will be easier to understand with example. Okay. So here, what is your q of x? Q of x is x cube plus x plus 1. Okay, and what is your p of x? P of x is 3x to the power 5 plus 6x to the power 4 plus 2x square plus x plus 1. This is your p of x. Now what I want to do, I want to divide this p of x. I want to divide this p of x with this q of x. So first thing what you will do, so first of all, you try to find out such a number, uh, such a thing, or such a you can say such a number or such a value of x, such that if you multiply this number with our polynomial, you will get the first term of your p of x. Okay, so here you can see that the first term of p of x is 3x to the power 5. And here, if I want to make this first term to be 3x to the power 5, what is the thing I want to multiply? So if you want to make x cube into 3x to the power 5, you can say that you can multiply by 3x square, right? Because if you multiply 3x square with x cube, you will get 3x to the power 5. So this factor is important to us. So at every step, we have to figure out that which factor we will multiply in our q of x, which will give us the first term of our p of x. Again, we are considering the first term. So that means, again, we have to consider that which factor we will multiply in the first term of p of x, which will give us the first term, which will give us the first term of p of x. Which factor we will multiply in q of x, which will give us the first term of p of x. This is the things we have to figure out at every step. Okay, so as I say that if you multiply here 3x square, you will get 3x to the power 5 as the first factor of your uh, multiplication, right? So this factor I will multiply. So I'll write down whatever multiplied factor I am multiplying, which is 3x to the power 2. Okay, please mute yourself. You have unmuted. I'll mute all. Yeah. So what we will do, we'll figure out those factor which will give us the first position back. Okay, so here in the first step, we will multiply by 3x square. So if you multiply by 3x square, what are the things we get? So we get 3x to the power 5. 3x square multiplied by x will be 3x cube. So plus 3x cube and plus 3x square. Now what we want to subtract the this thing in from our p of x. So I'll change the sign. I'll write minus. So this plus will change into minus. This plus will change into minus. And then I'll apply the operation. So here you can easily figure out that this term and this term will cancel each out. And here we have 6x to the power 4. But there is no term of x to the power 4. Right? So this 6x to the power 4 will stay as it is. The next term is 3x cube, and there is no x cube term in p of x, so that's why minus 3x cube stay as it is. Why minus? Because we want to subtract. So when you subtract, you will change the sign. Okay, now here we
Minus
have
x
2x.
square.
Sorry.
Minus x square.
Yeah, correct. Minus x square and plus x plus 1, right?
Yes, ma'am.
Now we will repeat this process until and unless we get any reminder which is less than this power 3. Okay, so we'll do this process repeatedly. Now we have 6x to the power 4 here. So what thing you will multiply in this factor
Six
to make
x.
6x to, right? 6x. So we'll say that plus of 6x. So you'll get 6x to the power 4 plus 6x square plus 6x. Again, we'll change the sign. Plus will change into negative, plus will change into minus. These two term will get cancelled out. Again, we have minus 3x cube here. Now minus 6 and minus 1 will become minus 7x square. Right? This is minus x square. This is minus 6x square. So it will become minus 7x square. Here we have minus 6. Here we have minus 6
Five
and
x
here we have plus 1. So it will be minus 5x and then
plus
plus 1.
one.
Right. Now again we haven't done yet, because what we want that here whatever power we will get, that power should be strictly less than the power of your quotient. uh, right. So this is the thing we want, but here we have cube, so that means again we can multiply something over this x cube to make it minus 3x cube, and that is nothing but minus
Minus
3.
3.
Right, so that is minus 3x cube minus
Minus
3x
3x.
minus 1. Right, again we'll
Minus.
change the signs and this will
Ma'am,
get
why
cancelled
can't
out.
it be minus 3?
Sorry, what?
Minus 3 into 1 is minus 3 only, no,
Oh,
ma'am.
yeah. So this is minus 3, right? So we'll get minus 7x square. Minus 5 plus 3 will become minus 2x, and here we'll get plus 4, right? So this is our remainder. So here whatever thing we'll get that is known to be remainder, it's generally denoted by r of x. This is your quotient, which is denoted by q of x. And this is whatever thing you want to divide, that is your p of x,
3x.
right?
Ma'am,
So,
ma'am,
Sorry,
x
what?
cube plus x plus 1 is, I guess, divisor.
Sorry, yeah, sorry. This is your quotient, right? So this is your divider. So ultimately you can write p of x in this way. So this is your p of x, this is your r of x, this you can say your q of x, and this is some another function b of x. So you can write p of x as this q of x multiply with b of x and plus r of x. As like in the real number that we can write uh, whatever quotient we have as the divider into something plus remainder, right? So same thing here. Okay, is that
And
clear?
ma'am, in the lectures, we are taught two methods to divide. So if we can do any one method, or we have to do both.
Yeah, you can do by anyone. It's up to you. Whatever thing you say,
Okay.
you think that it's simpler. I think this method it's much more simpler than the
Yes, yes, this one is simpler one.
so you can use this method too.
Ma'am, are we allowed to take calculators to the qualifier exam?
No, they will give you a built-in calculator. So there will be one TCS built-in calculator in your desktop, so you can use that calculator. You are not allowed to bring any electronic device inside the center.
Okay.
Okay. So here, as I say, that you can write down P of x as B of x into Q of x plus R of x. Okay. Now, one thing I want to say here about R of x is there is some restriction over the degree of R of x. So this is a remark you can say. As you guys observe that we stop our division when we got our R of x, which is one lesser than the degree of your divider, right? So here Q of x is of degree 3. So we stop our division when the degree of R of x become 2, right? So it says that if uh, if P of x yeah. So if P of x is returning as some B of x into Q of x plus R of x, right? So or you can say that if you are dividing P of x by Q of x, so if uh, Q of x divides whatever this is. So if we are dividing P of x by Q of x, then the degree of R of x, right? So this is the degree of R of x. So the degree of R of x will be strictly less than the degree of Q of x and greater than or equal to 0, right? So that is the degree of R of x will be greater than equal to 0 and strictly less than Q of x, strictly less than the degree of Q of x. It could be 0 because we know that, see, in this example, you can consider a simple example. If you consider P of x is equals to 4x square and Q of x is equals to only x square, then you can easily see that here, whatever R of x you will get, that is equal to 0. So that's why the degree of R of x could be 0. So that's why we are saying that the degree of remainder will be strictly less than the degree of divider Q of x. Okay, is that clear, this fact?
Ma'am,
Yeah.
in the lectures, the professor has taught us the some kind of formula for multiplication, addition, and subtraction. So do we have to
Yeah.
learn?
No, it's not compulsory. If you think that that method is tricky, you can always use this method because ultimately both are doing same thing, but this is more structured. That is not that structured. So that's why it seems a bit difficult because there you
Because
have
yes,
to.
and
Uh,
because there are in activity questions also there are some questions on that. So because that is complicated, so we're not able to learn.
okay. I'm audible, right?
And just
Yes,
now we
ma'am.
couldn't hear.
Ma'am, just now you got.
Okay. So I was saying that you can stick with this method too. So whatever method taught in the lecture, that's also doing the same thing. But if there are any specific question, I'll go and check and let you know if you need to learn that.
Okay.
But I don't think you have to learn because it's more than enough. Ultimately, we just want you to learn how to divide a polynomial, and it's more familiar, I guess. In your high school, you may have learned this method.
Yes, yes,
Yeah.
yes.
Yeah,
Right.
this is very convenient.
Okay. Okay, so now let's go to the next topic. So we have learned so far how to add, multiply, divide any polynomials. Now we will go to some basic terminologies of polynomials. So that is what are the roots or zeros of polynomials. Okay, roots or zeros of polynomials. So roots or zeros of polynomials are actually those values of x where p of x becomes 0, right? So these are those x belongs to real number for which p of x is equals to 0. And it's a very well-known problem to find the roots of any polynomials. So if I start with the basic polynomial, so that is a polynomial of degree 1 that you guys know that it will represent an equation of line. So it's very easy to find the roots of such a polynomial. So for example, if you have a p of x is equals to 3x plus 1, and if someone asks you find the roots of this polynomial, what you will do? You will simply set p of x is equals to 0. That means 3x plus 1 is equals to 0. That means x is equals to minus 1 by 3. Right? So it's very easy to find the roots of such a linear polynomial which has degree 1. Now let's suppose I'll increase the degree of polynomial. I'll go to the polynomial of degree 2. So suppose p of x is some x square plus 4x plus 4. So this is our quadratic polynomial, and we also know that we can find out the roots of this polynomial too by using the Sridharacharya formula, right? So what you will say, the roots of this polynomials are x is equals to minus b plus or minus under the root of b square minus 4ac by 2. You can use this formula by constructing that this polynomial is nothing but ax square plus bx plus c. So by comparing, you can find out the values of a, b, and c, and you can find out the roots. Yes, sir. Shahid, is there any doubt? Okay, fine. So that means we can find out the roots of quadratic polynomials too. Now let's suppose I'll increase the degree one more. So suppose p of x is equals to some x cube plus x plus x square plus x. Suppose this is a polynomial. So now it's in a very nice polynomial, right? So if you set p of x is equals to 0, you can easily figure out, okay, x cube plus x square plus x is there, it is equal to 0. So I can take common x square plus x plus 1 will be there is equals to 0. So this x is equals to 0 will be my one root, and another leftover is the quadratic one, so you can find out the root. But if you have more complex cubic polynomial, then the job of finding roots will become a little bit trickier. So there is one fixed method, but in our course we haven't discussed it. So in our course you can just go, so for cubic polynomials, you'll use hit and try method. Right. So I hope you guys are familiar. Hit and try method means just randomly put some number into p of x and observe that it's becoming 0 or not. That's the hit and try method. So although for cubic polynomials there is a general method, but it's a little bit complicated and we haven't learned in our course, so I am just skipping that. If you are interested, you can go and check, but it's no need. You can always lie on hit and try method, because we also give you the polynomials which can be solved by hit and try method only, or just by observation. For example, like this one, right? So as we increase the power of p of x, the finding root, the problem that you have to find the roots of polynomial become more trickier and trickier. So for q of x, that is for cubic polynomials, there is a method, and also for biquadratic polynomials, that is polynomial of degree 4, that is a4 x to the power 4 plus a3. Let me take the, suppose this is your degree 4 polynomial. Okay, again, finding the root of this polynomial is very tough job. There is again a method to find this roots. There is a method, but this method is not generally applicable, and also we haven't discussed in our course, so it's no need to learn that. But I'm just saying, just for sake of knowledge, that there is a method to find the roots of degree 4 polynomial too. But actually there is no method, or it's nearly you can say impossible to find the roots of x to the power 5 type of polynomial, that is degree 5 polynomial. So it's nearly impossible, you can say, to find roots of
Ma'am,
yes.
what is the best approach for the hit and trial method?
Okay, so best approach will be start with pair of integers. So that is start with 0, then go to plus or minus 1, then go to plus or minus 2, then go to plus or minus 3. If someone wants you to find out the hit and try by using hit and try method, they usually use these much integers only. Until and
Ma'am,
unless
can
it's
you
very
give,
obvious.
ma'am, can you give any example of hit and trial method?
I don't have, but you can say any polynomial of degree 1 minus 1. Uh, Suppose p of x is like this, x to the power 4 plus x cube plus x square plus 1. Okay, so suppose this is a polynomial, then here you can put p of
Here
minus
try
1,
negative numbers.
right? Random numbers you have to put. So if you put minus 1, you will get 0 here. So minus 1 is one root. So again, hit and try method means just you have to put random integers. So yeah, so in hit and try method, always put integers. It's not like they want you to substitute 1 by 2, 1 by 4 type of thing. No. If someone asking you a question on hit and try method, they are assuming that you will substitute integers mostly. Okay. So that's the hit and try method. So I was saying that it's actually nearly impossible to find the root of polynomial of degree 5 by hand or by arithmetic or right. So what we will do, we use the graph of polynomials to find the root of equation, or we use the graphical calculators, right? So there are many graphical calculators like Desmos, we have GeoGebra. So those graphical calculators will help us to find the roots of much higher degree polynomials. Okay, so this is the general thing about finding roots of polynomial. So I'll repeat what is the roots or zeros of polynomials are. So those values of x where the p of x is vanishing or p of x is becoming 0. Okay. Now let's go to the next point, which is the turning point of polynomials. So what are the turning points? So turning points of polynomials are those polynomials on which p of x is changing its nature from increasing to decreasing or decreasing to increasing. For example, consider this graph of polynomials. So suppose this is some polynomial. So at this point, suppose the set x is equals to a, what is happening? So before this point, p of x is of increasing behavior, right? It's increasing before this point. And after this point, it's decreasing, right? So here it is increasing, here it is decreasing. So such type of point is known to be the turning point of polynomials, right? So those points, or those x belongs to real numbers on which p of x changing its nature, you can say, right? So that is either increasing to decreasing or decreasing to increasing. Such kind of points are known to be turning point. And there is a fact that if you have a degree n, yeah, so there are two remarks you can see. One remark says that if degree of a polynomial p of x is n, then it can have at most n minus 1 turning point. So it is at most, it's not exactly. So they are saying at max or at most, I can say at max 2, we have n minus 1 turning points. And the reason behind this is because if you have a px is an n degree polynomial, then it can have at max n distinct roots, right? So this is the second remark you can say, that if degree of a polynomial is n, then it can have at most n roots. Again, I'm saying at most because you can simply consider the example of p of x is equals to x to the power 4, right? So this is a polynomial of degree 4 and it has only one turning point and one root, right? And one root. Why is this so? Because we can draw this polynomial. It's a very basic, simple graph. It's just like a parabola, but little bit flatter over 0. So here 0 is the only root and is the only turning point of this polynomial p of x is equals to x to the power 4. So here the degree of polynomial is 4, but it has only one turning point and one root. That's why we are using this word at most in both of the remarks. Okay, so it's always at most, not exactly. Yeah, there are cases where it is exactly, but remember that it says that at most n minus 1 turning point and at most n roots. Okay, is that clear? Any doubt over this fact? Okay. So now let's go to the even and odd polynomials and their end behaviors. And after that, we will construct the graph of some polynomials. Okay, because that's the important thing. You should know how to construct the rough graph of any polynomial if the polynomial is given in the factored form. Okay, so let's go to the even and odd polynomials. So what is even polynomial? See, even polynomial, even functions, odd polynomial, odd functions, both are different. So these four things are actually different definitions. So I'll list down all four so we can see. So I'll start with even polynomial. So even polynomial means that the degree of polynomial is an even number. Okay, so if the degree of polynomial is an even number, it's known to be an even polynomial. For example, you can take p of x is equals to x to the power 4. So its degree is 4, which is an even number, so it's an even polynomial. Now what is an odd polynomial? So odd polynomial means as usual as the degree we are saying, right? So that is the degree of polynomial is odd number. For example, p of x is equals to x cube, right? So this is a polynomial of degree 3 and 3 is an odd number. So that's why this is an odd polynomial. Now what is even function or odd function? So you guys learn this I think in week 1 we have even functions and odd function. But if not, you can also learn definition here. What is even function means? So a function with this property, right? So a function with f of minus x is equals to f of x property is known to be an even function, right? And what is an odd function? Is a function with the property that f of minus x is equals to minus of f of x. So if a function satisfies this equality for all x, then it's known to be an even function. And if a function satisfies this equality for all x, it's known to be an odd function. Okay, so that's why even polynomial, odd polynomial, even function, odd function, they have their particular definition. So always go by the definition. Don't get confused between even polynomial and even function. Okay. So, and you guys know that every polynomial is a function. So someone can ask you that every even polynomial is even function or not. You can think about such type of questions. Okay. So let's okay. So let's try to answer one question. So if I ask you that is the statement is true or false? So the statement is every even polynomial is an even function. So what do you guys think? Is it true or false? You can take 2 minutes to think. You know what is even polynomial is, you know what is even function is. So you have to think. If you think it's true, then it's true. If you think that it's false, then you have to construct an example to say that it's false. Okay, you guys are saying true. Are you see, there are examples, but in general I am saying. Okay, true, false, true, false. So actually this is a false statement. So I'll give you examples. So this is actually false. Why it's false? So you can consider a polynomial, simple polynomial, p of x to be only x square plus 1. Okay, so this is your polynomial x square plus 1. Yeah, someone also gives a nice example. See, x to the power 4 plus x cube 2. So I'll discuss both examples. X to the power 4 plus x cube. Right? So see, both are even degree polynomial because both are the power of x is the largest power of x is 2 and 4, which are even numbers. So they are even degree, even polynomials, right? So both are even polynomials. This is also an even polynomial. But does it satisfying the property of even function? So what is the property of even function? P of x should be equal to P of minus x for all x belongs to real number or domain. But here you can say that domain is nothing but the whole real number. That's why. So here it's not true because you can easily compute what is P of, so for one, no, it's an even polynomial actually. X square plus 1 if you take, it's an even polynomial. You have to take x here. Then it will change its sign, right? So here P of 1 you can calculate. So P of 1, I'm changing my example to be x square plus x. So P of 1 is actually, you can say that it's 1 plus 1, which is equal to 2. And if you compute P of minus 1, it's nothing but 1 minus 1, which is equal to 0. So here p of 1 is not equal to p of minus 1. So that's why it's not an even function. Not an even function. Same thing will happen in this example too. But here you can consider one little bit change. Suppose I'll take x to the power 4 plus 1, which I did earlier. So in this case, this is an even polynomial, also an even function. Why it's an even function? Because if you consider p of x, this is equal to p of minus x for all x belongs to real number. Why is that? Because if you take p of minus x, that's equal to minus x to the power 4 plus 1, which is equal to x to the power 4 plus 1, which is your p of x. Right? But the statement generally says that every even polynomial is an even function. So this every word making this statement false. So there are even polynomials which are not even functions. Okay, so that's why this statement is false because of the every word. Okay, so this is the one thing you can say. You can also play with these four things, like you can consider now odd polynomial even function, odd polynomial odd function, and you can check which are the statements which are true or false on those things. Okay, so I'll leave to you.
Excuse me, ma'am.
Yeah.
Ma'am, can you please explain this even function and even polynomial once again?
Yeah. So see, first of all, consider the definition. So even polynomial means this polynomial word we have. So polynomial, for every polynomial we have defined a degree. So if the degree of that polynomial is an even number, we say that it's an even polynomial. Okay. If the degree of polynomial is an odd number, we say it's an odd polynomial. But there are also two terms which are known to be even functions and odd functions. So even function means we have a function, and with that function we have a property, right? So if a function satisfies this property, that function is known to be an even function. Okay. So that is a function with f of minus x is equals to f of x for all x belongs to their domain. If this is true for all x, then it's an even function. Okay. So even function has its own definition. It says that any function with this property is known to be an even function. Similarly, we have defined odd function means any function with this property. So there is change in minus sign. So in even function, f of minus x is equals to f of x. In odd function, f of minus x is equals to minus of f of x. So if a function this satisfy this property, it's known to be an odd function. Okay. Now the statement says every even polynomial is an even function. So is this true or false? So for saying that it's a false statement, we have constructed one example. So here you can consider this example: p of x is equals to x square plus x. So here this p of x is in what is the degree of p of x? So here degree of p of x is 2, right? So which is an even number. So that's why it's an even polynomial, right? So obviously it's an even polynomial. Now we have to check for even function. So even function's definition, what does it says? It says that if it's an even function, then p of minus of x should be equal to p of x for all x belongs to real numbers, right? But we have two real numbers for which this is not this is not true. So we can simply consider p of 1 and p of minus 1. So if you compute p of 1 will be 1 plus 1, which is 2, and p of minus 1 is 1 minus 1, which is 0, right? Because minus 1 if you substitute minus 1, you'll get 1 minus 1, that's why 0. So here what is happening? P of 1 is not equal to P of minus 1. But if it's an even degree polynomial, it should be equal, right? So it is not satisfying the definition of even function, right? Not satisfying the definition of even functions. So that's why it's not an even function. So there are even polynomials which are not even functions. Okay, is that clear now?
Yes,
So
ma'am.
ma'am,
Ma'am,
every
in the
even function
second
with
example,
even polynomial.
No, so even function consider several type of function. You can take sine, cos, and all those things, right? So those are not polynomials. So the converse is also not true, right? Functions not need not to be always a polynomial, right?
Sine
It
cos
could be
can be
sine,
written
cos,
in
tan.
form of polynomial.
Sorry, what?
But sine cos can be written in the form of
No,
polynomial.
no, no. They are not polynomial. They are infinite series. So series and polynomials are they are actually very different kind of things. So sine, cos, you can write out in terms of series. Those are not polynomials. So polynomial, see, in polynomials, we have finitely many terms. If you have infinitely many terms, it's called to be series, not a polynomial. Okay,
Okay.
cool, fine.
ma'am,
Yeah.
so in the first example, this is an
Mhm.
example where a polynomial is even, but it's not an even function.
Correct,
And in the second example, it's an even polynomial, but and also it's an even function.
correct, correct. Yeah.
Okay, ma'am.
Okay, is that fine? Okay.
Yeah.
So now let's move toward the graph of polynomial. But before that, I want to discuss the end behavior of polynomials, how the end behavior of any polynomial will look like. Okay, because this end behavior will help us to draw the rough graph of a polynomial. Okay, and also we need two points for discussing the graph of polynomial. One is the end behavior. Another one is the nature of polynomial around its neighborhood or zero. So I will discuss these 2 points, and then we will figure out how to construct the graph of polynomial. Okay. So first of all, what is the end behavior? Okay, so end behavior means you just have to figure out if x goes to infinity or x goes to minus infinity, where does this function p of x or polynomial p of x goes? Where does it goes? So that's the main question we want to answer. Okay, so for that I'll categorize polynomials into two different things, even and odd polynomial. So you'll learn why I'm doing this. So I'll start with an even polynomial first. Okay, so I'll take one example. So even polynomial, suppose I have a polynomial p of x is equals to x to the power 4. Okay, so here you guys will answer that these things. So what is the limit? So it's better not to use limit word because we haven't defined it. So suppose we have a polynomial p of x is equals to x to the power 4, and here if I say if x goes to infinity, then where does p of x goes? Where does it goes? If x
Ma'am,
goes to
infinity.
infinity, correct?
Infinity.
Because it's kind of obvious. If you take larger value of x, its fourth power will be again larger value. So if x going to infinity, that means p of x is also going to infinity. Now, if I ask you if x goes to minus infinity, then where does p of x goes? Infinity, again infinity. Why infinity? Because if you take minus number, its power 4 will become positive, right? So it's always going to infinity. You can also judge this thing by the graph too. So this is the graph of p of x is equals to x to the power 4. Suppose it's touching at 0. Sorry for my drawing though. So this is the graph of p of x is equals to x to the power 4. So by the graph also you can judge the same thing. So here you can observe that if x is going to infinity, so here x is going to infinity, then the values of p of x are getting bigger and bigger and bigger. So that is when x is going to infinity, these values are also going to infinity. And here when x goes to minus infinity, because we know that over x-axis, in this direction, if you move forward, in the right hand side, if you move forward, you will go to plus infinity. And in the left hand side, if you go forward, you will reach to minus infinity. Not reach, you will go toward minus infinity, right? So here, if x goes toward minus infinity, you can observe that still p of x is going toward plus infinity only. Because over y-axis, these are the plus 1, plus 2, and so on values, right? And these are the negative y values. So by the graph also, you can judge that as x goes to infinity, p of x goes to infinity, and as x goes to minus infinity, p of x is also going to plus infinity only. Okay, so is that clear? Okay, so now same thing happens for every even polynomial. So there is nothing special about x to the power 4. So you can consider in place of x to the power 4, this kind of nature happens for every polynomial. Okay, for example, that means what I want to say is that is if you have an even degree polynomial, and here you can see that the coefficient of x to the power 4, that is the coefficient of largest power of x, is a positive number, right? Plus 1. So here you can say that a4 is positive number, strictly greater than 0. So this is the fact that if you have an even degree polynomial, so if p of x is an even degree polynomial, so suppose it is a n x to the power n plus a n minus 1 x to the power n minus 1 k minus 1 plus and so on, plus a1x plus a naught, and here n is an even number, that is it's an even degree polynomial, that is even polynomial with the plus condition is the an, what is the largest, or the coefficient of largest power is strictly greater than 0, that means an is positive. Then in this case, when x goes to infinity, p of x goes to infinity, and when x goes to minus infinity, then also p of x goes to plus infinity only,
Infinity.
right? So this is the fact. There is nothing special about x to the power 4 because what happened in a polynomial, the largest power of x dominate the nature of polynomial. So that means the nature of this polynomial x to the power 4 is kind of similar to the nature of x to the power 4 plus 1 or x to the power 4 plus x cube plus x plus 1. There could be little bit changes, but when we are discussing about end behavior, the nature of all these polynomials will be similar. So the whatever the largest power of x is there, that actually dominates the nature of any polynomial. Okay, so that's why we are considering only even, we are dependent over the degree of polynomial. So if it's an even degree polynomial with the positive coefficient, right? So with this particular condition, an is strictly greater than 0, then as x goes to infinity, p of x goes to infinity. As x goes to minus infinity, p of x still goes to infinity. Okay, is that clear, this case? So we'll discuss 4 cases, 2 even polynomial cases, 2 odd polynomial cases. So the next case will be when an is less than 0. So that case you can understand with minus of x to the power 4 polynomial. Okay, and if you are getting confused with x to the power 4, you can also reduce it to x square. So I always use these two polynomial. One is p of x is equals to x square and another one is p of x is equals to x cube to remember the end behavior of polynomials. Okay. So any even degree polynomial will behave like p of x is equals to x square or p of x is equals to minus x square. I mean, you guys are, you know what I want to say. The answer of these questions is x goes to infinity or minus infinity. Okay. So this is our first case. Now second case is when we have even degree polynomial or even polynomial with the coefficient an is less than 0. That is negative coefficient we have. So you can take an example of p of x is equals to minus x square. Right. So here this is the graph of p of x is equals to minus x square. It's a parabola, downward parabola. And here you can answer the questions now. So as x goes to infinity, what do you guys think? Where does this p of x goes?
It will go to minus infinity.
Minus infinity, correct? Because here if x is going to infinity, you can easily observe that the values of p of x is going to minus infinity. Right. Similarly, I can ask the second question is x goes to minus infinity, where does p of x goes?
Same, minus
Same,
infinity.
minus infinity. Right. So this is the second case with even polynomial, but the coefficient of largest power is less than 0. Okay. So this is the end behavior of even polynomials. Similarly, we can discuss about odd polynomials too. So suppose I have odd polynomial with the coefficient of the largest power is again positive. You can consider the example of p of x is equals to x cube. Okay, so this is the graph of x cube. It's something look like this. Okay, so here can you guys tell me if x goes to infinity, then where does p of x goes?
Infinity, positive
Infinity.
infinity.
Right, because as x goes to infinity, you can observe the graph, it's growing toward positive infinity. Right, now when x goes to minus infinity, what do you guys think? Where does p of x goes?
Minus infinity.
Minus infinity. Right, by the graph only you can observe that it's going toward minus infinity. Okay,
Yep.
now I can consider the next case too. Let me know if I am moving too fast.
Oh, it's clear to me.
Sorry, what?
I can understand.
Oh, okay. Yeah, just checking the message in the chat box. He was saying that every even polynomials are example of even functions, but even function can be much more than just polynomials. Yeah, that's correct. But our examples you can say, because there are some even polynomials which are even functions. So next case is odd polynomials with the largest coefficient to be negative. Okay, less than 0. You can consider the example of minus x cube. So I'll give you the graph of minus x cube function. It's actually, so whenever we change from x to minus x, what happens? The graph will reflect about y-axis, right? You can observe that so this is just a fact for you guys, that if you observe the graph of f of x and f of minus x, the only changes, these two graph are mirror image of each other over the y-axis, right? So when you construct the graph of x cube, you can easily flip this graph over y-axis. You'll get the graph of minus x cube. Okay. So this is the graph of minus x cube. Okay. So here, what do you guys think? As x goes to infinity, where does p of x goes?
Minus infinity.
Minus infinity, right? Just by the graph infinity, this is going to minus infinity. Going to minus infinity. Now, if x going to minus infinity, where does p of x goes?
To infinity.
Plus infinity. Right? By the graph, it's kind of clear. So this is the end behavior of any even or odd degree polynomial. Okay, so I'll write down it in a table. So again, I'll give you the hint that, okay, always consider the graph of x square minus x square, x cube minus x cube, whenever you feel confused about the end behavior of any polynomial. Okay, so I don't think it's needed to write down in a chart, but we can take some example to say what do you guys think about these. Okay, so I'll ask you a question. Consider p of x to be equal to x to the power 4 plus x cube plus x square plus x plus 1, and q of x is minus x to the power 5 plus x square. Okay, p of x is equals to this, minus x to the power 4 minus x cube minus x plus 1. Okay, and if I ask you, if x goes to infinity, p of x goes to, what will be your answer?
Infinity.
Infinity, right?
It-
Because p of x is an
Yeah.
even degree polynomial, so that's why it goes to infinity. Now, if I ask you if x goes to infinity, where does q of x goes?
Minus infinity.
Minus infinity.
Minus infinity, correct? Because it's an odd polynomial with negative sign, right? So odd polynomial negative sign means it changes its behavior. So that means minus x cube graph, you can imagine. Okay, so now I'll ask you this question. So suppose if x goes to infinity, so where does px plus q of x goes?
Minus infinity.
Minus infinity.
Minus infinity, correct? Because p of x plus q of x will be polynomial of degree x to the power minus 5, right? So if you consider p of x plus q of x, you will get minus x to the power 5, x to the power 4, x to the power 4 cancel out, x cube cancel out, but that doesn't make much difference. Whatever things are here, we don't bother about that. We just bother about the largest power of x with the sign. So here we have minus x to the power 5, that is odd polynomial with negative coefficient. That's why it goes to minus infinity. Okay, so I hope it's clear. Now I'll ask last question. So as x goes to infinity, same thing, as x goes to infinity, where does p of x into q of x goes? What do you guys think?
I
Where does
guess
the
minus
multiplication go?
infinity.
Minus infinity.
Correct, minus infinity. Why it goes to minus infinity? Because here you can figure out the largest power of p of x and q of will be x to the power 9, right? Because minus x to the power 5 multiplied with x to the power 4 plus x cube plus so on. Here you will get the largest power will be minus x to the power 9, right? X to the power 5 multiplied by x to the power 4 will give you minus x to the power 9. So that is again
Yeah.
odd polynomial with minus coefficient, that is minus infinity. Is that clear so far?
Yes.
Okay,
Yes, ma'am.
fine. So this is the end behavior of polynomial. Like, now you can easily figure out where does a polynomial goes when x goes to infinity or minus infinity. Okay. Now there is another thing, that the behavior of polynomial on their roots. Okay. So what happened on roots? So there are actually two kind of things happen at roots, and it's depend on the multiplicity of roots. So what is the multiplicity of a root? So multiplicity of a root means, first of all, you guys know if x is equals to a is a root of p of x, then x minus a divides p of x, right? This fact, I think it's clear. It's kind of clear. When x is equals to a is a root of p of x, then you can factor out p of x. So there will be a factor of x minus a in p of x, right? Is that clear? It's very easy. You can easily see. Suppose you can take an example like we know that x is equals to minus 1 is a root of P of x is equals to x cube plus x square plus x plus 1. Right? You can just substitute P of minus 1. That is minus 1 plus 1 minus 1 plus 1, which will give you 0. So here x is equals to minus 1 is the root of this polynomial, and you can easily divide. You can easily see that x minus 1 divides this polynomial x cube plus x square plus x plus 1. You can just see by using the division. I'll just do it quickly. X minus 1. So here you'll get x square. That will give you x cube and minus of x square. So minus got plus. Cancel out 2x square plus x plus 1. Let me know if I'll make any mistake. 2x. So 2x square minus x minus 2x. Minus
Plus
will get
1
plus. Right, 3x plus 1.
plus x plus 1.
Ma'am, we should divide by x plus 1, na?
Oh, yeah. That's why I thought why it's not getting because yeah, correct. X plus 1. Thank you. So see, if x is equals to a is a root, then x minus a is a factor. X minus a. So here minus 1 is the root, so we have to divide by x plus 1. So if you divide by x plus 1, x cube is there, again we have to make x square, so that is x cube plus x square. So these two will get cancelled out, x plus 1 we have, so just only plus 1. Yeah, that's why I see what is happening. So you can easily see x plus 1, and this will again cancel out, the remainder will be 0. So that means this x plus 1 is completely dividing our polynomial. So it's true in general. So if you have x is equals to a is the root of polynomial p of x, then x minus a is a factor, or you can say that x minus a divides our polynomial p of x. So now what happened, this p of x or any polynomial can be write down in the multiplication of its factors of roots, or factors where each factor is a root. So what I want to say is any polynomial, you can say that any polynomial p of x can be written as that p of x can be written as x minus alpha 1 to the power r1, x minus alpha 2 to the power r2, and so on, x minus alpha k to the power rk. I'll explain what is this power means. So here you can see, so suppose I'll take another example. Suppose you have a polynomial p of x is equals to x to the power 4 plus what I want 4x square. Suppose this is a small polynomial, p of x is equals to x to the power 4 plus 4x square, or I can take minus x. Okay, so now if you want to factor out this polynomial, what will be the most common step is take out the x square common, right? X square, x to the power 4 minus x square minus 4, sorry. Right, so you can take common x square from both of the terms, you will get x square bracket of x square minus 4. Right, this also you can write down x square into x minus 2 into x plus 2, because this 4 is nothing but 2 square, so a square minus b square formula if you apply, you'll get x minus 2 x plus 2. So this is p of x, right? So here you can observe that although the power of these two factors are 1, but the power of x is 2, and this x can be written as x minus 0 whole square, x minus 2 into x plus 2. So that means it is possible to get more than one factor for a single root. So here you can see that 0 is a root, but x square divides p of x. So that is x minus 0, the whole square divides p of x. So that means this 0 root is repeating twice, kind of thing is happening here, right? So it is possible to get the multiple factor with the same root. That's what the point I want to make. So same thing can happen in general too. So you can say that a polynomial p of x can be write down as this type of thing, where what is happening, where each of the alphas are actually roots of the polynomial. Okay, so where what are these alpha i's? So here alpha i's are actually roots of the polynomial, roots of p of x. And here whatever ri you will get, or whatever the that means how many times that factor is dividing our polynomial, that number is actually known to be the multiplicity of the root. So here ri is the multiplicity of root alpha, right? So that means r1 is a multiplicity of root alpha 1, r2 will be the multiplicity of root alpha 2, and so on. Okay, so here multiplicity actually plays what you can say, a good role in how the polynomial will behave around its roots. So that's why we have to know what is the multiplicity of each root. Okay, so multiplicity means how many number of time that factor is appearing in the expression of p of x. Okay, so that's the multiplicity. I'll take one example. So suppose in this example also you can see. So what will be the multiplicity of root? So here we know that there are three roots: 0, +2, -2, right? So here all the roots are 0, +2, -2. So what are the multiplicities? So the multiplicity of 0 is, what do you guys think? What will be the multiplicity of root 0?
So 2.
2, right? Because this factor is appearing twice. X minus 0 square. So this 2 will be your R1. So the multiplicity of root 0 is 2. What will be the multiplicity of +2?
1.
1.
1. Correct. Because the power of this factor is 1. There is nothing means there is 1. Okay. So what is the multiplicity of root -2? Similarly 1, right? Okay. Now I'll ask you guys this question and answer in the chat box. Okay. So suppose p of x is like this. X minus 10 to the power 3, x minus 5, x plus 5, x minus 10 to the power 4, x minus 5 square, x plus 5 cube, x minus 1 to the power 9. Okay, so here you can easily, okay, now you guys answer this question in the chat. Okay, don't speak aloud, in the chat you can answer. So what is the multiplicity of x is equals to 10? Okay, so some people got confused that it will be 4 or 7 or what. So actually, the multiplicity will be 7. So what you have to do whenever such kind of polynomial is there, first of all, you have to rearrange that polynomial in a nice way. Okay, so that means you have to first write down its, that what is the total power of x minus 10 factor. So total power of x minus 10 factor is 7. So there are 3 factors are here and 4 brackets are here. So total there are 7 brackets. So this will be 7. And how many times x minus 5 is appearing? So one factor is here, so 1, and 2 factor is here, so that is 3. How many times x plus 5 is appearing? 4 times. And x minus 1 is appearing 9 times. So now you can say that the multiplicity of x is equals to 10 is 7. Okay. So that's why it's multiplicity of the root x is equals to 10 is 7. Is that clear? Okay. If you guys have any doubt, you can just unmute yourself and let me know. Okay, fine. So now, regarding multiplicity, so as we learn now what is a multiplicity means, just the number, how many times that factor is occurring in our expression p of x. That is the multiplicity of that particular root. For example, here the multiplicity of x is equals to 10 is 7, because this x minus 10, the power of this bracket x minus 10 is 7. That's why it's 7. Similarly, you can count the multiplicity of others too. So now there is a, you can say that, okay, so multiplicity is again a number. So you can say that multiplicity will be even or odd. So based on the multiplicity, polynomial behave differently around its root. Okay. So here, suppose one thing I want to say. Yeah. So degree, the, if you sum the multiplicity of every root, that number will be less than or equal to the degree of p of x. Okay, so I don't remember that this fact is covered in our lectures or not. So the thing is, if if p of x is can be written as yeah, or else I'll just write it down, that sum of the multiplicities, sum of the multiplicity of roots is less than or equal to equal to the degree of p of x. I want to specify the reason for less than or equal to is because it can happen that we can get complex roots. So then in that case, we actually don't have factor of for those things. So that's why we are using x less than or equal to thing. For example, let me take one particular example. Suppose p of x is your polynomial looking like x square plus x plus 1 and x square minus 4. Okay. So if you consider this polynomial p of x, you can see that this is a polynomial which has no real roots. Right? Why it's not have no real root? Can someone tell me why this x square plus 1 won't have any real root?
Discriminant is negative.
Correct. So that is the value of b square minus 4ac. If you calculate here, that is 1 minus 4, which is minus 3, which is less than 0. So since the discriminant of quadratic polynomial is less than 0, it won't have any real root. So that means this factor does not have any real root, and this factor will have two real roots. So it's x square plus x plus 1, and we have x minus 2 and x plus 2. So in this case, we just have only two roots, 2 and minus 2, and the multiplicity of their multiplicities are 1 and 1. So the sum of multiplicity is, so here, I'll write it down everything. So the multiplicity of x is equals to 2 is 1. The multiplicity of x is equals to minus 2 is also 1. So thus sum of multiplicities is 1 plus 1, which is 2, which is strictly less than degree of polynomial p of x. What is the degree of this polynomial? What is the degree of this polynomial p of x? 4, right? 4, correct. Because here we have x square. So if you multiply and simplify it out, x to the power 4 will be the largest power of x. So that's why degree of this polynomial is 4. Okay. So that is sum of the multiplicity is actually strictly less than the degree of polynomial. So that's why I have written here less than or equal to. So because of complex root scenario, we can get less than or equal to thing. That the multiplicity of roots is less than or equal to the degree of p of x. Okay. I hope that's clear.
Simplicity,
Yeah.
firstly, we need to find roots.
Yeah, firstly you have to find roots, but what happened? They will give you polynomial in factored form only, because we know that finding roots is a complicated thing. So they will give you polynomials of this type of thing. So it will be easier to judge how to judge it will be very easier to judge the multiplicity of any root. Is that okay? I think that's the thing you want to ask, right? Okay, fine. So now let me write these two notes, which will be helpful for us to draw any graph of polynomial. So notes are, first thing is, if the multiplicity of x is equals to alpha root is even, then p of x behaves like this thing. So that means if you have this x is equals to alpha, then you know that alpha is a root of polynomial. So polynomial definitely touch this point x is equals to alpha, because here it's becoming, the value of polynomial is becoming 0. But what happened when then the multiplicity of root is even, then polynomial just go and touch the root of this x, touch the x is equals to alpha and return back in the same direction. So that means if p of x is coming from this particular direction, it will just touch the point x is equals to alpha and return back in the same direction. Okay, so this is happening because the multiplicity of alpha x is equals to alpha is even. So you can relate this with the graph of x square, right? So in the graph of x square also, x is equals to 0 is the root of even multiplicity is 2. So here also same thing happens. So whenever you have a root of even multiplicity, the graph of polynomial just go and touch that point and return back in the same direction. Okay, so the same scenario can happen in the other way around too. That means,
Excuse me, ma'am.
yeah,
Ma'am, here in this statement you mentioned that if multiplicity is even, Ma'am, is it does it mean that sum of multiplicities is even or just the highest degree?
Yeah, multiplicity of this factor. So that means here, what is the multiplicity of 10? Multiplicity of 10 is 7. So that means overall, how many factors are there? That's sum. For this particular 10, I'm talking about one root, not the entire sum.
Okay.
Okay, right? So that number you have to consider. Okay, so same thing can happen. Suppose in place of p of x is coming from the positive direction, it can happen the p of x comes from this direction. It will touch the root and return back in the same direction. So this thing happens when you have root with even multiplicity. Okay, is that clear? It
Excuse
will
me.
be much clear. Yeah.
Ma'am, in the previous example, how is the degree of polynomial 4?
Yeah, see, here this polynomial is written in the factored form. Once you solve it, you get that x to the power 4 plus something, something, something. Though that will be less than 40. So the largest power of x is 4. That's why the degree is 4. Okay.
Yes.
Okay. Now what about if we have odd multiplicity thing? Okay. So the second remark says, suppose, so if the multiplicity of root x is equals to beta is odd. So that is, it's an odd number, any odd number, 1, 3, 5, any odd number. Then p of x will behave like this. So what happened? It will now, in this case, it will intersect x-axis and continue in the next quadrant. Okay. So what does that mean is, so suppose this is your x is equals to beta. Then if p of x is coming from this direction, so at x is equals to beta, it will intersect x-axis and continue into the next into the same direction. It won't change its direction. Okay, so it's kind of like straight line behavior, you can see at that particular. Okay, so same thing can happen from the other way around. Means it can comes from this direction and continue in the next quadrant. Okay, so that means the moral of the story is, when it's a multiplicity of root is odd, it will intersect x-axis, and if the multiplicity of root is even, it will just touch that point and return back in the same quadrant or the same half plane. Yeah.
If the multiplicity is odd, and is it necessary that that line intersecting is a straight line?
No, it's not equal. Yeah, it's not necessary. It could be anything else, but it it will be little bit. So that means if you zoom in, it will behave like a straight line. So near, very close to that root, you can say. Okay, not
Thank you.
necessarily the straight line, but similar kind of behavior as like a straight line. Fine. The point is, it will intersect x-axis and go and continue in the next direction. Okay. So I hope these 2 points are clear, because we need these two facts to draw any polynomial. Okay, that's the thing. Now let's try to draw one polynomial. So first of all, suppose I have a polynomial p of x is equals to, suppose I have minus 20 here, x minus 10 to the power 5, x plus 10 to the power 6, x minus 1, x minus 5 square, x plus 5 cube, and suppose I'm taking x cube here. Okay, so suppose this is some random polynomial I'm taking. I don't know what will be the graph of this polynomial looks. Okay, any random polynomial. And now what we want to roughly estimate how the graph of this polynomial will look. Okay, just a rough diagram we want to see. So what I'll do, first thing is, first of all, I'll observe the end behavior. Okay, so what is the end behavior? So as x goes to infinity, what do you guys think? Where does p of x goes? Okay, so it's better to check with the
Minus
degree first.
infinity, I guess.
Yeah, so what is the degree of polynomial p of x?
6.
Just sum the factors. That's all.
19,
19, right? So you can simply sum, because see what happened from this thing, you will get x cube. When you open this bracket, you will get max power of x is x to the power 5. So that means from this one you will get x cube, From this factor, you will get x to the power 5 as the largest power. From this guy, you will get x to the power 6 as the largest power. From this one, you will get x square as the largest power. And from this one, you will get the x cube as the largest power. And everything in the multiplication. So the degree of polynomial will be 3 plus 5 plus 6 plus 2 plus 3. I suppose it's 19. Right? So 11, yeah, 19. 17 plus 2, 19. So the degree of polynomial will be 19. Okay. So 19 means it's an odd number. So it's an odd polynomial. Odd number. But the thing is, the coefficient here is minus 20. Now, someone can, just for confusion, they can write down like this thing. So in place of x minus 10, suppose I have written down 10 minus x. Then you can take common x, you can take common negative, and the coefficient will become positive. So that's how anyone can confuse you about the coefficient, right? So you have to take care of the thing is, it should be written in the terms of x minus alpha. Okay. So this is our x minus 10. So here it's an odd degree polynomial with a(n) is less than 0. So that means we can recall the graph of f of x is equals to minus x cube. So that graph look like this. So that means as x goes to infinity, it goes to minus infinity. And as x goes to minus infinity, this p of x goes to infinity.
And
Is that clear? Hand behavior?
yes.
Yes.
So how this hand behavior will help you? Let me show. So suppose first of all, what you will do whenever you have to draw a polynomial, just plot the points. So here plots the roots. Points means roots. Okay. So here you can see. So can you guys tell me what are the roots of this polynomial?
X equal
Yeah.
to 0 and
X
then
is
10
equals to 0. X is equals to 10. X is equals to
minus
minus
10,
10.
Minus 10,
Minus
X is
10,
equals to 5.
5.
X is
5,
equals to
minus
minus 5.
5.
minus 5.
Yeah. So let's also write down the multiplicity of the roots. Okay. So what will be the multiplicity of 0? 3.
1,
3, right? Because x
3.
cube is there, right? X cube means x minus 0 the whole cube. So multiplicity will be 3. Multiplicity is nothing but the power of that factor. That's all. Is that
Yeah.
clear?
Yes.
What is the multiplicity of 10?
5,
5,
5,
Minus 10?
6.
6.
6. Right? 5 will be 2. Minus 5 will be 3. Right? So you have to take care of this thing, right? When you talking about x is equals to 10's multiplicity, you have to consider the factor x minus 10, not x plus 10. Okay. Okay, I hope that's clear. But these are the multiplicities.
Yeah.
Okay. Now, first of all, we'll plot down the points. So that is x is equals to 0 is there for us. Then we have 5. Then we have 10. Then we have minus 5. And then we have minus 10. Okay. So what is happening at those roots? We know if it's an even multiplicity root, polynomial will go and touch it and return back in the same direction. And if it's an odd multiplicity root, it will continue. But the thing is, how to start drawing the polynomial. So that means there are two ways to draw a polynomial. So suppose at minus 10, it could possible that polynomial can come from this direction or it can come from this direction. But how can you guys figure out that from which direction this polynomial is coming, right? So that is the initial direction, how we can figure out what will be the initial direction, right? So this direction can be figured out by the end behavior,
And
right?
behavior.
Right. So because here as x is going to minus infinity, p of x is going to infinity. So that means polynomial is coming from the upward direction,
Second quadrant.
right? Second quadrant. So because if it's not from this direction, if it's coming from this direction, then you can say that as it's going to minus infinity is going to minus infinity. But it's not the case, right? So that's why end behavior will tell you how you have to start drawing your polynomial. That means from which quadrant you have to start drawing your polynomial. Is that clear? That our polynomial will come from second quadrant.
Yes.
Is it clear to everyone why I'm starting from second quadrant?
Yeah.
Okay. Yeah. So yeah, so now the polynomial is starting from here, and obviously it will reach to x is equals to minus 10. But what happened at x is equals to minus 10? At x is equals to minus 10, we have multiplicity 6, so that means it will just go touch the point x is equals to minus 10 and return back in the same direction. But what is happening? It has to. I mean, the polynomial should also reach to x is equals to minus 5 point, because minus 5 is again the root with multiplicity 3. So that means for reaching minus 5, it has to turn once, at least once. Okay, it could be, or sorry, not at least, exactly once. Because if it turns, uh, here also we have complex root scenario, but at least it has to turn once to reach the point x is equals to minus 1, right? So it will turn once, and what will happen at x is equals to minus 5? So since at x is equals to minus 5, we have odd multiplicity, so it will intersect here and continue in the in the same direction. So that means it will now it will go into the third quadrant.
Third
But
quadrant.
again, we have to return to point x is equals to 0. So this polynomial should have at least one turn, and then it will go to the point x is equals to 0. But again, what is happening at x is equals to 0? We have odd multiplicity, so it will intersect the point x is equals to 0 and continue in the same direction, right? Again, the same thing will happen for x is equals to 5. So we have to return at x is equals to 5, but at x is equals to 5, the multiplicity is even, so that's why it will touch and return in the same direction. But again, we have to reach at x is equals to 10, so it will reach at x is equals to 10, but the multiplicity at x is equals to 10 is 5, that is odd, so it will intersect and continue in the same direction. So this will be the rough graph of your p of x. At max, changes can happen is this loop. So that means I have drawn this smaller loop. It could happen that it will be a bigger loop, or like this, something like this. So this is the rough graph of your polynomial. Okay, is that clear how we have drawn this graph?
Yes.
Okay, so now let's try
Yes,
to
ma'am.
compare our graph with wait a minute. So let's compare this with Desmos, right? So this is our initial graph. Can I share multiple screen?
Yeah.
Okay, so let me share. So let's compare this one with the Desmos graph. Okay, so this is the Desmos calculator. So I'll just insert our polynomial here. So it starts with x cubed. So x cubed, then we have x minus 10 to the power of 5, right? Then we have what we have, x plus 10 to the power 6, no? So this is 6, x plus 1. I hope my screen is visible, right?
Yeah, it is.
And then we have square here, 5 here, and then we have the last vector of cube here. 5. Okay, so it seems.
Last one is plus 5.
Oh, yeah, plus 5.
X plus 5.
Okay, so see, this is the graph which is very unusual for us. So at max, these kind of thing will happen. So I think I have taken the wrong example, or maybe roots could be at larger distance. So in place of, I'm just making it so that it will look good. Okay, that's why I'm inserting zeros. So let's see what will happen. Still, it's not looking good. But yeah, it could be something like similar. I think I have taken a very bad example, but it's okay. I think it depends on the coefficient too. Okay, it's not looking good, but fine. I can change the coefficient and all those things. So ultimately, it will be similar kind of thing. So that's why I was saying that at max it can happen that this loop will be very big, and then then it will return back. But this is the rough estimate of our polynomial. That's how you draw any point. Okay, is that clear so far?
मैम आपने सेकंड क्वाड्रेंट से क्यों स्टार्ट किया?
Yeah, because of the end behavior. See, end behavior is saying us that when x is going to infinity, when x is going to minus infinity, p of x is going to infinity, right? This is the end behavior we have. So suppose in place of second quadrant, if I have started from third quadrant, then what does it mean? It means that as x going to infinity, p of x also going to minus infinity. But this is not the case we have. We have x goes to minus infinity, p of x is also going to infinity. That's why I have started with the second quadrant.
Okay.
Is that clear?
Yes.
Yeah, just because of the end behavior. And this
Ma'am,
end behavior ultimately follows.
Ma'am, I have a question.
Yeah.
Ma'am, you discussed about adding all the multiplicities.
Yeah.
But I did not. Maybe I missed a point. What is the usage of adding the multiplicity of all the roots?
It so far it doesn't give us any information. You can say that by adding. So if you have the scenario when the addition of multiplicity is less than the degree, then in that case you can say that okay, we might have some complex root. But so far there is no use for us. That's why it's important.
Okay.
Okay. Now I'll give you a graph, and based on that graph, you guys try to answer some of the question related to a polynomial. So that means now we have discussed one way that if we have a polynomial, how to create a graph, a rough graph, obviously. And now the second point is, if we have a graph, then can we figure out some things about polynomial? Is that okay? So far, any doubts?
no, but I have one actually. We could have also started from quadrant 4. Like why we are starting from 2 and going to quadrant 4?
Yeah, because of the end behavior. See, end behavior says, so suppose you have started with quadrant 4. Suppose you have started with this thing, right? Then what does it mean? It means that when x is going to minus infinity, the values of p of x is also going to minus infinity. Correct?
Yeah.
But
Ma'am,
our
he
end
asked
behavior
quadrant
is saying
4.
like this one.
But I'm saying
Quadrant
if
3.
we could have also
Quadrant
started
4.
from quadrant 4 actually. So like how we are determining this thing that it will start from quadrant
Okay,
2.
okay, okay. Oh yeah, got it. So quadrant 4, na. So that means you want to
Yeah.
start from here. That's also fine. No, it doesn't affect. You can start with 4. You can also start with 2. It's up to you.
Yeah, initially
Although,
I was actually imagining that from quadrant 4. That's why I was asking.
oh, it's okay. So it's up to you from whatever quadrant or whatever end behavior you want to use, you can use, because the other one automatically follows. So that's
Got it.
the thing. Mhm.
Got it. Thank you.
Okay.
Ma'am,
Uh,
here can you explain turning point, ma'am?
yeah. So here turning point. So for us, turning points is nothing but those points where nature is changing. So you can say that okay, this is one turning point. This is another one. This is third, fourth, fifth, sixth. Right. So you can easily count the turning points of this panel. So there are 6 turning points.
Ma'am, can you please repeat this graph, how we drew it?
Yeah, okay. So suppose, first of all, you have to figure out based on the end behavior where you want
Excuse
to
me,
start.
ma'am. Ma'am, can you
Yeah,
take another example of another graph and do it again?
yeah, we can take that. So I'll take one example. So let me take one example from PYQs. I think there is one example. Or else I can take general example. Forget about PYQs. Okay. So here I'll give you guys 5 minutes. Try to draw a graph by your own, and then I'll discuss. Okay. So suppose p of x is equals to minus 1 upon 1000, x to the power 5, x minus 5 cube, x minus 2 square, x plus x plus 3, 5 minus x to the power 5, and I'll take one more factor, x plus 10 square. So suppose this is your p of x. And now just try to draw the graph of this polynomial by yourself, and then I'll discuss it at 9:40. Okay, just take 4 minutes, try to draw in your copy, and then you can easily judge that you are understanding it right on. Okay. First of all, observe the expression of p of x. Once you guys have done it, just message done in the chat so that I'll know how many people have attempted.
I think I'm done.
Okay, just wait for a minute for this to finish.
Okay.
How to draw a graph of it? Graph of it. Of it.
Sorry?
Sorry?
Please.
हम तो एक से बारी दो हेल्प कर रही
Yeah, okay, so let's start draw session.
Yeah.
Okay, so let's start. So first of all, as we have discussed, we will first figure out the end behavior. So what is the degree of p of x here?
18.
18th. And since I have just write down this factor as 5 minus x to the power 5, you have to rewrite it in terms of x minus 5 to the power 5, and the minus will become will make this coefficient to be positive 1 by 1000. Right. So here we have an even degree polynomial with en strictly greater than 0. Is that clear? What you have to do?
Yeah.
Yeah. So we know that as x goes to infinity, it's just an even degree polynomial positive coefficient. So you can remember the graph of x square. So x goes to infinity means p of x also goes to infinity. As x goes to
Infinity.
minus infinity also, p of x goes to infinity.
Infinity.
Right. So now, that means if you want to start with, no matter from which side you want to start, you can start from left, you can also start from right. But if you start from left, you have to start from the second quadrant only, because again we have the scenario as x goes to minus infinity, p of x goes to minus infinity, p of x is going to infinity. Or else if you want to start from the right side, you have to start from the first quadrant. Because here we have scenario when x goes to infinity, p of x is going to infinity. Right? So no matter which side you will start, the graph will be similar. Okay. So that's how our polynomial will start and end. Now we'll just plot the roots and its multiplicities. So I'll make column. So here we have roots. Here we have their multiplicities. So one thing we have to do is x minus 5 cube is there, x minus 5 to the power 5 is there. So combiningly we can write down it as x minus 5 to the power 5 plus 3, which is 8. Right? So then that factor will eliminate. So we have roots 0 because of x to the power 5 is there. We have root 5 because x minus 5 factor is there. We have root 2 because x minus 2 factor is there. We have root minus 3 because x plus 3 factor is there. And we have root minus 10 because x plus 10 factor is there. So there are how many factors? 1, 2, 3, 4, 5. Different, right? So there will be 5 roots. Is that clear so far?
Yeah.
Okay. Now what are the multiplicities we have to check? So the multiplicity of 0 will be 5 because x to the power 5. So that means 5 x minus 0 factors are there in p of x. So that's why multiplicity is 5. What will be the multiplicity of the root 5?
8.
It will be 8. Multiplicity of root 2 will be 2. Minus 3 will be 1 and minus 10 will be 2. Correct? Now
Yeah.
I'll just plot the roots. So roots are, suppose this is minus 10. Minus 3, we have 0, we have 2, and we have 5. Right. So now let's start drawing the point. So it will start from here. It will go to the point x is equals to minus 10. But minus 10 has even multiplicity. So that's why it will touch and return back in the same direction. It will go somewhere. But again, we have to reach the point minus 3. So we have to come back at minus 3. Since the multiplicity of the root minus 3 is 1, it will intersect the x-axis. It will go again. But again, we have to come back for the point x is equals to 0. So it will return back. And the multiplicity of x is equals to 0 is 5, which is odd. So it will intersect x-axis, move into the next quadrant. But again, we'll have to return back for the point x is equals to 2. But at x is equals to 2, the multiplicity is 2, even. So I'll again return back. I'll go to point x is equals to 5. 5 also has even multiplicity, so it will again return back and go into the same line. Okay, so this is your rough graph of P of x. Is that clear? Any doubt?
There are 7 turning points, right?
Yeah, 1, 2, 3, 4, 5, 6, 7. 7 turning points. Less
And
than
it
the
can
number of
have,
roots.
and it can have at most, what was the 17, I
17
guess.
turning points. Yeah, it can have at most. No, this polynomial cannot, but any degree 18 polynomial can have at most 17 turning points. You can take the example. Suppose I'll give you this example of this polynomial. P of x is equals to simply x minus 1, x minus 2, up to x minus 18. Okay, so this polynomial, if you draw, then this polynomial will have 17 turning points. Why
I
it will
got it.
have 17 turning points? Because you have to come back 18 times, right? So since it's a polynomial of even degree with positive coefficients, it starts from here. I'll go to 1, 2, 3, so it will like this. So that's why 17 turning points will be
I got it.
there. Okay. Okay, so now let's quickly observe the other way around scenario and then we can wind up our session. I hope this so far it's clear. Any doubt about any point or any topic?
No.
Okay.
More
Ma'am, it is
multiplicity.
similar to AB curve method.
AB curve method. AB curve method means that method na, for judging the inequalities, right?
Yes.
No, no, ma'am. Equality. nahi. It means
Inequality.
Inequalities,
it is
inequalities.
yeah similar to
Ha,
that.
ha, ha. Yeah, you can say similar, but yeah, almost similar.
Ma'am,
Okay.
can we plot the polynomial to Desmos?
We can plot, but the thing is, because I'm taking random numbers, the graph is not looking that good. So let me check for this polynomial too. So it's minus of 1 by 1000. If it looks good, I'll share my screen. Otherwise, I won't share my screen.
Okay.
It's x
It
to the
would be
power.
fun, looking to that.
Yeah, I also thought that, but since I'm taking random numbers, it's not looking good at all. So x cube is there, x to the power 5, 8. Two. It's not looking good at all. I mean, it's just like parallel lines. It's not.
Okay, no issues.
That's fine. Okay. Now we can go other way around. So now I'll give you a graph of a polynomial, and you guys can tell me some properties about that polynomial. Okay. So suppose graph is like this. Okay. So suppose this is the graph of a polynomial P of x. So I'll ask you a question. So first of all I'll just mention some points. You guys know this is origin. Suppose this is x is equals to 10. Suppose this is x is equals to minus 5. Okay, so that's
How
that's
can
all.
it be minus?
Hey, sorry, how can it be minus? Correct. X is equals to 5 actually. So first question I want to ask is what will be the max degree of, or sorry, what will be the minimum degree of
9.
P of x? Okay, 9. Can you explain the reason too?
8 turning points. So 1.
Correct. Right. So that means here you can judge. You can for answering question for answering this question, you can take help of turning points. Okay. So since there are how many turning points? 1, 2, 3, 4, 5, 6, 7, 8 turning points, right? So there are 8 turning points. So we know that if we have 8 turning points, then the degree then the degree should start from 9, right? Because it cannot be 8, it cannot be 7, it cannot be 6, 5 and all. So it should start from 9. It could be anything else, but it should start from 9. So that's why I have written down minimum. So that means because of the 8 turning point, the degree of p of x is obviously greater than or equal to 9, right? Because of the fact, because if we have degree n degree polynomial, then at max we have n minus 1 turning points. So you can use this fact to say that, okay, since we have 8 turning points, so the degree should be 9 or bigger than 9. Okay, so that's why I'm asking minimum degree could be 9. Okay, so the
Ma'am,
degree, yeah.
ma'am, but other than these 8 turning points, okay,
Huh? See,
okay,
by
ma'am,
the graph only.
yeah, ma'am, I was thinking that are we taking the number of times the graph is touching the x-axis, or
No, no, no,
is it
no.
purely on the
The
turning?
turning point means this up and down only, not touching the x-axis. Only up and down for us. Because we haven't gone in detail. There are actually other things too, but for a starting point, the turning point means this curve pattern only. That's all. Okay. So that means the minimum degree of this polynomial could be 9. Is this question clear to everyone? Why the answer is 9 and what I want to ask is
Yes.
fine. Fine. I hope that's fine. Now another thing is you can also judge it by multiplicity too. So as you guys say, you can also judge it by turning point, but you can also judge by multiplicity. Okay. So you can count down the minimum multiplicity of each root. Okay. So what is the smallest odd number? What is the smallest odd number? 1, right? 1 is the smallest odd number. Correct?
Yeah.
Yeah. And similarly, 2 is the smallest even number. So see, here at this point, the polynomial is intersecting x-axis. So you can say that, okay, the multiplicity of this root could be, again, I am using the fact that addition of multiplicity is less than or equal to degree. Okay, that fact you can use. So here multiplicity, minimum multiplicity could be 1, right? So here also minimum multiplicity could be 1 because of the intersection. Here also 1, here also 1. Here it is,
2.
since it's touching the x-axis and returning
Sorry,
back, so
0.
minimum 2, right? Multiplicity I'm talking about.
I get it.
So minimum multiplicity means, yeah, so since it's touching and returning back, so that means minimum, it will be of even multiplicity. But I want to have the guess of minimum degree. So that's why the multiplicity will be, minimum multiplicity will be 2. So here minimum multiplicity would be 1, here also 1, here also 1. Now what is the sum? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here sum of the multiplicity is 9, but in that fact we have n, so that's why the answer still remains 9. Okay, and also answer won't change no matter from which method you will go. You can go by turning points too, you can go by multiplicity, counting the minimum possible multiplicities too. Okay, so if
So the
yeah,
sum of multiplicity wouldn't be 10, like cannot be 10 in this
uh,
case.
yeah, minimum if you count,
Okay.
can't be 10. Because we are taking minimum even and minimum odd number, right? 1 and 2.
Yeah.
So that's so these are the question I can ask since we okay. So yeah, one more thing we can figure out is that is so what do you guys think, is this even polynomial or odd polynomial? Is this even or odd?
It's odd. Odd.
Odd polynomial, right?
Yeah.
Because of the end behavior, right? So
Yeah.
it's if you think that as since x is going to infinity, it's going to infinity, is minus infinity, it's going to minus infinity. So that's why it's an odd polynomial. Only odd polynomial will have such kind of end behavior. So by end behavior, you can answer that. So the answer is okay. One more thing I can ask based on the graph is this thing. I want to ask what will be the sign of largest coefficient. So I want to ask this thing, that if p of x is equals to a n x to the power n plus e n minus 1 to the power n minus 1 plus and so on plus e1x plus e naught, then an is greater than 0 or less than 0. What do you guys think? An is greater than 0 or less than 0?
It's greater than 0, I think.
Are you guys agree with him? Because
Greater than 0 it should be.
correct, it should be greater than 0, but because of the end behavior again, the same reason. So that means en should be greater than 0. Because of the end behavior, obviously. Okay. So yeah, these are the type of question you should be able to figure out, that based on the graph, looking at the graph, you can tell what will be the minimum degree. It's an even degree polynomial or odd degree polynomial and all those things. Okay. Fine. About the polynomials, we have so many interesting things. So when you guys learn about continuous function, you can say that every polynomial is actually a continuous function because they are the nice functions. We know all things about them. Also other things we can figure out when we move ahead in our course. Okay.
Ma'am, I have one question.
Yeah.
Ma'am, suppose they say that, there's a question that a polynomial goes through a particular coordinate. Suppose it says 2, 3.
Okay.
So, and there is a function given for the polynomial, and it says that it passes through a coordinate 2, 3. So, should I understand that if I replace the value of x with x coordinate, so the overall answer I should get, which should be equal to the y coordinate?
Correct. Yeah. So that means if a polynomial is passing through the point a comma b, so that means if you substitute x is equals to a, you will get p of a to be equal to b, because that's how we draw any graph, right? Or passing through a graph means.
Yes.
Yeah, it was the question from graded assignment 3, I guess.
Okay. Yeah, you should understand like that. If a point is lying over any graph, then whatever x value is there, if you substitute that x value in your function, you will get back your y, get back the y value. That's the meaning of point lying over a graph or lying over any function. Okay. We haven't gone through one function in detail, right? One injective function. Yeah, we can see those properties in week 5 too. So far that's all from week 4. That's all we have from week 4. What are the things I can say? Yeah, that's all. You guys can now you can try all the questions, activity and practice. And if you have any doubt, we can discuss those doubts in the next session. So if you have any doubt over the theory, you can ask now.
Intermediate theorem is in the syllabus or no?
Yeah, polynomial in the syllabus. It's in the
No,
syllabus.
intermediate value theorem.
No, it's not in the syllabus. Intermediate value theorem is not in your syllabus. It's not even in the course. Intermediate value theorem, it's not in our course.
So in the last second lectures, which professor taught about that?
Intermediate value theorem. No, I don't know.
He
But
gave
yeah,
only definition.
only definition he might have given. But intermediate value theorem, it's a good result, but it's not in our course. Okay, so I'll upload the PDF of this notes over the calendar. So down the Zoom link, you can find a link to the notes. I haven't uploaded yet any notes, but I'll upload this notes because I think I write down in.
Would you also clip the YouTube link for this because it's not in the calendar?
Okay, yeah. I'll tell sir to upload that YouTube link.
Thank you.
When that will be available, ma'am? That YouTube link will be available to tomorrow, or how much time it will take?
No, it could be available tomorrow, by tomorrow or by end of the session. So I'll check with him. And I'll see.
Okay.
Or else if someone is joining from YouTube, you guys can also paste the link. Someone I think already did pasted the YouTube link. Yeah, this is the YouTube link, I guess, right?
Yeah, I've dropped in chat.
Hmm. Okay. Okay, then if you guys don't have any doubt, we can wind up our session here. If you have doubts over polynomial theory or polynomials, you can let me know. I'll be here for next 5 minutes.
Ma'am, can you please summarize what all the things we have seen today? So
Yeah.
it'll be.
So we have started with general definition of polynomials. Right? So what is a polynomial? So for us, polynomial is any function which look like this: an x to the power n plus an minus 1 x to the power n minus 1 plus and so on plus e1 x plus e0. This is the general expression of polynomial, where we are assuming the largest coefficient is non-zero, that is an is not equal to 0, and all other coefficient belongs to real numbers. So this is a polynomial for us. So we have understand how we can add to polynomial, subtract to polynomial, multiply and divide to polynomial. Multiply to polynomial, and what is the meaning of division of two polynomials. So here also we understand that what is the relation between the degree of remainder r of x and the degree of q of x. So we got that the degree of r of x. So here the important fact about division is that the degree of remainder r of x is actually strictly less than the degree of q of x and greater than equal to 0. It could be 0 because we can get 0 as a remainder. So that's why. So this is the important fact when we learn the division of two polynomials. So there are two methods. One is explained in the lecture and another one I have done, which is much more familiar to you guys, because we have done division of polynomial in that manner too. So no matter, I think no matter which method you will use, you will reach to the same conclusion. Okay. Now after that, we have learned about what are the roots of polynomial and what are the methods we can use to find out the roots of polynomial. So it turns out if a polynomial is of degree 1, 2, 3, then in 1 and 2 we have explicit methods, or I can say that it is possible to find uh, uh, every polynomial's roots if its degree is 1 or 2. But when you jump to 3, it's kind of become little bit difficult, and we haven't discussed any particular method to solve cubic polynomial. So we'll just use hit and try method to solve this type of polynomials. And for the larger degree, we don't have any particular method, and in general also there is no particular method to solve 5-degree polynomial. So we can use the help of graphing calculator. So we want to understand the graphs of polynomial, and if a graph of polynomial is given to you, then how we can extract the information about that polynomial. So for that, we have learned so many things about a polynomial. So one is the end behavior of polynomial. So end behavior means if x is running towards infinity or minus infinity, we want to answer that where the values of polynomial goes. So the fact is the largest power of the polynomial, or so whatever the largest power is there, that power dominates the whole nature of polynomial. So that means if you have 3 polynomials, suppose x cube plus, okay, suppose I'll take larger power, x to the power 7 plus 5x square plus x plus 1. This polynomial, or x to the power 9, not 9, x to the power 7 plus 6x square plus x plus 1, or only x to the power 7 polynomial. So here, at the end, these 3 polynomial will behave nearly equivalent when we go toward the largest values. So that means as x goes to infinity, all these 3 polynomials p of x will goes to infinity. So that's why we only judge the end behavior of polynomial based on their degree, if it's an even or odd. So that's only matter to us when we talk about end behavior of polynomial. So if it's an even polynomial or an odd polynomial. Okay. So with even odd, we have two more cases those cases based on the largest coefficient sign. So if it's greater than 0, then we have some different behavior. If less than 0, we have some different behavior. But as I told you, you can always consider the graph of y is equals to x square, y is equals to minus x square, y is equals to x cube, and y is equals to minus x cube to remember these behaviors. Right? So this graph is like this graph is like this graph is something like this, and this graph is something like this. Okay, so that's how the polynomials graph will look. Oh, and then we have figure out what is the multiplicity of roots. Okay, so multiplicity means how many. So we know that if x is equals to a is a root, then x minus a factor divides the polynomial. So that means a polynomial can be written down as the multiplication of factors of their roots. So now here we want to calculate that how many times a factor is repeating in our expression. So that the power of that factor is known to be the multiplicity of root. And then we learn that over the multiplicities, so if a root has even multiplicity, then polynomial behave a little different there. And if it's a root of odd multiplicity, then polynomial behave a little different there. So we use this fact to draw the polynomial too. Then we have also learned about what is the turning point and what is the facts about turning point and degree of polynomial, as well as multiplicity and degree of polynomial. Okay, so and then we just try to draw the polynomial combining all these facts. Okay, so that's how that's all those things we have done so far. Okay, fine. Is
Yeah,
that clear?
okay.
Any doubt? Okay. Okay, then see you in the next session.
Excuse me.
Yeah.
Can you please take up the activity question number 1 from activity 3.5?
3.5 question number 1.
एक्सक्यूज मी मैम ये सेशन
Yeah.
सेम रहता है क्या वो रिकॉर्डेड लेक्चर जो रहता है या कुछ अलग रहता है इस सेशन
नहीं सेम
सेम ओके
रिकॉर्डेड लेक्चर्स मींस कौन से रिकॉर्डेड लेक्चर्स सर ने
वो जो
किए?
हम हाँ यस मैम
हाँ नहीं कंटेंट सेम है, बस थोड़ा सा एक्सप्लेनेशन का अलग हो जाएगा.
हाँ ओके
हाँ कंटेंट तो सेम है, वॉट एवर देयर इज इन लेक्चर दैट कंटेंट इज ओनली वी आर फॉलोइंग. So
Okay.
slope line. So slope of line which passes through the vertex and the y-intercept of the quadratic equation is. So this is the question now from
Yeah.
activity 3.5.
Yeah, yes.
So here they are asking about the slope of line which passes through the vertex. Okay, so vertex you can calculate. So vertex of this p of x, this quadratic polynomial is x square plus 10x minus 5. So vertex you can find out the x coordinate of vertex will be minus b by 2a and y coordinate will be p of minus b by 2. Okay, so this point you can easily check.
The answer is
pass it.
my answer is coming as 7, which is not matching any of the options actually.
Oh, okay. So let me solve this one. So we have here p of x to be x square plus 10x minus 5. Right, so the vertex x coordinate will be minus b by 2a, so that is minus 10 by 2. So that's minus 5. Right, so x coordinate is minus 5. If you substitute minus 5, you will get 25 minus 50 minus 5. Right, so that this will be minus 25, that will be minus 30. Correct?
Yes.
I think, yeah. So one point is minus 5 and minus 30. Another point is y-intercept. So another point is y-intercept of this polynomial, this function. So y-intercept means if you put x is equals to 0, whatever y value you will get. So here y
Minus
value is
5.
minus 5. So this is also the y-intercept of the line, right? So you just have to figure out the slope now. Okay, so by the slope intercept form, you can say that this is nothing but y is equals to y2 minus y1 upon x2 minus x1. And 1 point slope formula you can use, or okay, so here that will be y.
2ax plus b.
Yeah, so y minus 5 is there, so y plus 5. So slope we have to calculate, right? So slope will be 30 minus 5 we can do 30 plus 5 and minus 5 minus 0 into x plus 5, right? I am using 2-point formula, any formula you can use. 5 plus 5, what I want to calculate? The slope of line, right? So slope is only we need to calculate. So yeah, so the answer is coming to be 5 now.
Yes. So I took instead of -5, I took 5 actually.
Right, because slope is minus 30 plus 5 by minus 5.
Yes.
So that is minus 25 by minus 5, so 5. Okay.
Thank you.
Okay.
Ma'am, can you explain codomain and domain?
Okay, yeah. So see, there are two different point of view you can say for domain. So general definition of domain is very simple. So what is a domain? So domain means if you have a function, so if f is a function from a set A to B, then this set A is called as domain. Okay, but this definition also means that domain is actually, what does a domain means? So domain is actually collection of all those points, collection of all those points where function is well defined. Where function is well defined. So what is well defined means? Well defined means two things. First of all, it should not be a complex number. Second of all, it should not be plus or minus infinity. So that's the two things we want to avoid. So whenever someone asks you to find the domain of function, means they want you to filter out all those real numbers which are which are giving us a well-defined value of a function. That means it should not be plus or minus infinity. It should not be a complex number. Okay, for example, if you consider the function f of x is equals to 1 by x minus 3 and x plus 5. So can you tell me what is the domain of this function? Can you guys tell me what is the domain of this function? So is there any, are you guys listening? Am I audible?
Yeah, you are audible. I guess domain will be not 3, not 3
Not
and
equal
5.
to 3 and not equal to
Yeah,
minus 5.
correct. Because what is happening at x is equals to 3 and at x is equals to minus 5, this function is not giving us a finite value, right? So that's why the domain of this function will be real number minus 3 comma minus 5. Okay, so that's a meaning of domain. Domain means collection of all those real numbers where a value of function makes sense. Make sense means three things is there. Should not be a complex number, not equal to plus or minus infinity. A complex number I am saying because you can consider the root under the root function. Under the root function over the negative, right? If you have negative under the root, it will be a complex number. That's why. So that's the meaning of domain. And codomain could be any set which is codomain depend to person or person. For example, I can say that f is a function from real number to complex number. I can take codomain depend person and person. So if the codomain is not given to you, you can assume that codomain is real number. Otherwise, they will mention specific codomain. So codomain is this right hand side set. Whatever the function output is, so the set of output you can say.
So domain
Possible
will
set of
be subset of codomain, right?
No. Domain is not subset of codomain. Range is subset of codomain. Codomain could be
Okay.
entirely different. For a very simple example, I can take. Suppose A is a set with ABC and B is a set with 1, 2, 3. And I'm defining a
Okay.
function A is going to 1, right? So here domain and codomain are entirely different. But the range is a subset of codomain.
Got it.
Okay, then okay guys, see you in the next session. And now we are done with our things. So
Okay. Thank you.
okay, thank you guys
Thank you,
for
ma'am.
joining. Bye.